Hello once again, everyone. Welcome to another edition of our Fronius webinar. These are webinar series where we tend to present to you a series of webinars covering Fronius products and solutions. So today we shall be discussing integration of third-party monitoring for Fronius inverters or with Fronius inverters. So we're going to basically be talking about how Fronius communicates with the outside world, or basically talking about data acquisition, processing, and dissemination with the use of Fronius inverters while communicating with other third-party devices, basically. So to do this with me today is none other than Byron Kotzer. So Byron is Technical Sales Advisor for the Southern Africa region. He is based in Johannesburg, South Africa. Of course, myself, Cyprian Okolo. I'm based in Lagos, Nigeria, and I'm the Technical Sales Advisor for the Western Africa region. So let's have a look at what we shall be discussing today in the agenda. So we shall quickly start off with an overview of SolarWeb Query API. And then we shall have a view of how to make API calls, and then look at SolarWeb Query API and REST. We'll find out what that means eventually. And then Byron will continue with onboarding, contracts, costs, and sales. And then we'll be providing further information afterwards. Great. So before we start, please feel free to ask your questions during the webinar. We shall endeavor to answer all your questions during the webinar. But in the case where it will take us longer, of course, we will reach out to you via email. Yes, so your opinion, of course, is very, very important to us. So we'd like you to give us a feedback about the content of our webinar. Thank you very much as we continue. So let's have a quick overview of this acronym, SWQ API. So SW basically stands for SolarWeb, and then Q stands for query, and then API. So what's API? So basically API stands for Application Programming Interface. So it's basically an interface that allows for communication between two entities. So in this case, it's an interface that allows for the communication or sharing of data between two applications, usually a client and a server. So in this scenario, the SolarWeb database is the server, while the client or the end user is the client application. And of course, the communication medium is over the internet. So that's basically what we shall be discussing today. So in this case, the server basically, which is the SolarWeb, stores and provides PV system data via the API or the interface. Good. So going forward, I will be referring to the acronym as API. So basically knowing that we are referring to the SolarWeb as the database or the server. Good. So just wanted to give us a bit of insight or context, to put it in context of what the SolarWeb API, how it all works. So let's say we have two entities, that is the customer's application or the client, and then the SolarWeb as the server. And then we have a query, that is a request for information that is sent from the customer's application. And then, of course, via the API, this information is, the request is made to the SolarWeb server. So what it does is basically to extract the answers to this query and then sends it across the internet to the customer's application. Of course, if you look closely, they look gibberish in nature. So there has to be some decoding that is done. So this customer's application has the capability to decode this information and then transforms it to readable data that eventually finds its way to the screen the customer. So it makes it quite readable and understandable. And this information now helps the client to make informed decisions. So that's basically how the API works. So going forward, the SolarWeb Query API, of course, we now know that it's an interface that allows us to programmatically access data from SolarWeb. So we have potential use cases ranging from companies providing solar apps with the need to integrate SolarWeb data. And then, yeah, also those that needs SolarWeb Query API, companies who want to offer new services based on SolarWeb data to their respective clients. So this could include integrating it into smart home platforms or for extended generic energy applications. And then, of course, we also have cases where companies that want to analyze production data for research purposes so as to improve energy forecast. So what can we do with this API? First off, we can, of course, get PV system data or information. We can use it to access aggregated energy data, and then also use it to access historical data for PV systems or for specific devices or inverters, as the case may be, in the system. Yeah, we can also get real-time data for PV systems or for specific devices. We can, of course, get service messages, and then, of course, weather forecasts of the respective PV systems. So from all that I've mentioned, I believe we can, of course, perceive what benefits actually comes with API. First up is easy data integration in existing or new applications. And then, of course, it can be used practically in any programming language. Of course, talking about ease of use. So because of that, it makes it really easy to communicate with Fronius devices and, of course, extract data from it onto the client's respective application platform. So let's now have a quick look at the key features of the API. So we have what is called representational state transfer, short or nicknamed RESTful API. So this is basically an API that uses HTTP requests to either get, put, post, or delete data. And then, of course, it can be used practically by every programming language, which, of course, signifies its ease of use. Still talking about key features, filtering can be done, which means that you can specify particular data that you want to extract or to request. So this could be on different channels, say just want to get energy info, consumption data, or frequency. So yeah, so you can kind of filter down specific data that you would want to request. It is also possible to page data, meaning that in a case whereby you have large amount of data that can be extracted at once, you can actually page it so that you don't have to get too much data at once, because these data tends to come at a cost, of which Byron will be discussing later. So in order to kind of minimize cost, of course, go straight to the point and getting the exact data that you want, you can, of course, page the data. And then, of course, it's also possible to provide or analyze error codes. So let's have a look at API calls and how we can make them. API calls basically queries or requests for information from Fronius inverters or systems. So what kind of calls or requests or data can be requested from the API? So we can get aggregated data, PV information, power flow data, historical data, service messages, and of course, meteor data. So we shall be looking at these calls respectively. So let's talk about PV system information. So what kind of information are we talking about here? So we can derive information about the number of systems or PV systems linked to the user's account, as you can see in the screenshot, list of all the PV systems, detailed information about the PV systems, and of course the devices in the system. In terms of aggregated data, you can of course get energy production and consumption data in aggregated order over the systems or devices whole lifetime, over a year, a month, or a day. So you just take your pick, and it will be served to you exactly as requested. In terms of historical data, data points are logged at the inverter every 5 minutes. So this kind of gives you the client the opportunity to have historical data right from the inception or the installation of the device till date as requested. So you can either have it for the entire system or for a single device in a given system. So this historical data could include power, like mentioned earlier, or reactive power, total power or reactive power, as can be seen in the screenshot. In terms of power flow data, so this involves real-time data for PV system or a single device of a given system. Yeah, so you could get production or consumption data, power from or to connected battery, and same or likewise with that of the grid. For service messages, yeah, so with service messages, you can get state and error codes, and with that, will enable the client to analyze the codes, tell the meaning, and of course, make informed decisions with regards to these codes. So they can come for the entire system or for a single device of the given system. As you can also see from the screenshot, we have in this column here, we have the status codes respectively. So with them comes the description of the codes, and of course, this gives you an idea of the reason for the errors, and of course, also gives you an idea of what actions to take eventually. So meteor data is actually restricted. It's accessible only for SolarWeb Premium subscribers. So with this, you're able to access weather and PV yield forecast data for a given system. So with this, you're able to get, like I mentioned, meteorological information, which actually plays a very, very important role in decision making with regards to storage and usage of storage facilities. So yeah, so like earlier mentioned in the agenda, let's now have a look at SolarWeb Query API and REST. So what is REST? So as earlier mentioned, REST basically is a representational state transfer. So this is basically a software architecture that helps in defining the set of constraints to be used for creating web services. Just basically helps for smooth communication between the server and the client. So the client could either be a tablet, a PC. Now we'll talk about the OS, the operating system. It could be Android or an iPhone app. So with the REST architecture, it makes the communication between the server and the target customer or client makes this communication quite easy, because the information being requested could come in different forms, and these codes would have to be decoded per se. So with the REST, it makes it pretty easy to interpret and decode the message, basically. So For RESTful data, just as earlier mentioned, it just provides feasible interoperability between the server and the client, just to put it simply. Yeah, so if we want to have a look at what it looks like in real life, basically. So this is basically how it looks like. But I'm going to save us the stress of going through the gibberish and give us a more simplified look at what an API call would look like in the subsequent slides. So that we will do, of course, by defining what Swagger is. So basically, Swagger is an open source framework and software that allows or helps developers to consume or make use of RESTful web services. So with this, it makes it possible for user interface developers to test and try the Solar Web Query API. So we're going to be having a look at this in the subsequent slides. So how to use it? So basically, after logging in, you would have to seek authorization by clicking on the authorization button. Grab my highlighter. Yeah, just at the top right hand of the screen, as you can see in the screenshot. So once you click on that, you would now have to enter the respective values for the access key ID, access key value, and then the bearer API key. So once these values are keyed in, then you can now have access to try out or test these API queries. So next up, you can, of course, get an overview, which basically looks like this. So you have the aggregated data on the left-hand side, and each of them has the respective queries that are possible to request for. And then once you make your selection, you would now have to go ahead to fill up or fill in the fields or parameters that you are requesting information of. So in order to make it a bit more clearer, I have to disengage this. Yeah, so I have this link that will take us straight to the website where we can, of course, try our hands on. So let's see if this connects. Yes, indeed. So this will definitely take us to the SolarWeb API. Now, just as you've seen in the slides, so this takes us to the SolarWeb Query API platform. So here you can, of course, you'd have to authorize, like I mentioned. So once you click on this, you would now have to enter all the necessary information in this space. So once you do that, you will now be able to authorize your use of this particular platform. So here you can actually get aggregated data of the entire system per year or per the entire period of the inverter or PV system existence in terms of months, days, years, and the likes. Apart from that, you can also get information about energy flow, historical data, general information, meteor data, permissions, system messages, and schemas, as you can also see. It's just giving you basic information about the entire system or specific devices in the system. So yeah, so this is basically a summary. Yeah, so I think this was worth the while to have a good look at it using the link. So I believe that actually was very useful. So, but all we need to do, of course, is to ensure that we get all the authorization details. So I believe Byron will be telling us more about it and how to get it when he takes over. So yeah, I of course mentioned error codes. So what kind of error codes exist? So in terms of REST APIs, the codes comes in different sets and series. So let's have this one, for example. So you could have a code 200, which is basically an OK code telling you that the query was successful, basically successfully executed. You have a 204, which tells you, yeah, there's actually no content, but the request was successful, but then there was no data. And then 400 tells you that, yeah, you must have made a mistake during the request, so the request malformed. So there are other sets of error codes that could come in different manners, but the good thing is that there's always a description and also a solution that is profiled for each of the error codes. So in all, we have general error codes that we could use to classify these error messages. So in terms of error classification codes for general cases, it usually comes in the 10 series, authentication comes in 11 series, metadata comes in the 30 series, flow data 31 series, and the rest, as you can see on the screen. Great. So with that, I've come to the end of my part of the presentation. Byron will be taking over from here to continue with onboarding. Byron?
Thanks, Cyprian. So next is the onboarding process. So from here, there's a general for the SolarWeb Query API onboarding page is available only from the Fronius network and only for a limited group of employees. So the page has two tabs, one for paying customers that are onboarding, and the second one is for trial runs that are being done by such customers. So you see, you'll have your contracted users and also the trial users. So for example, if you want to test out using the SolarWeb Query API, it is possible to do a trial run to see if you can make use of the data queries that you want to do, pulling the data directly from SolarWeb, and how exactly you want to process it. If you feel that it is viable for you to then use it, then you can do a contract between us, Fronius, and also yourself as the end customer. So for this, you would need beta access. So it's only available in certain customer countries. So please check the rollout status of the customer's country if you're wanting to make use of it. It's only granted for users in countries with the beta status and not for non-markets. So if your country is approved for the beta access, you can then make use of the APIs. So countries where the rollout is already finalized and marked as yes, you can please forward the customers from this country to Inside Sales. Again, no beta access is possible and a contract is required when you are then finalizing. So is the customer a business or business customer, for example? So it was decided that the SolarWeb Query API is only available for business customers. So end customers are not qualified for the SolarWeb API. However, it is enough if the user is linked to a company account in CRM respectively, if the customer clearly conveys you that he plans to use the SolarWeb Query API commercially. So for example, with any software companies that want to extract the data and then do their own analysis of that data. So if both requirements are fulfilled, either contact a person on the sales department or create a ticket at the TSI ticketing system to then continue with it. So the contact person for the contracts. So the conclusion of the contract has to be done between the sales rep, so it'll be the technical advisor for your region, and the customers itself. So the pricing and payment conditions have to be agreed between both parties. And as soon as the contract has been handed over to Fronius, Inside Sales, is responsible for the onboarding of the customer itself. So once the document filing has been done, they will then grant that API access via SolarWeb. So there are multiple steps when doing the API contract itself. So you'll do a handover and the API contract and the latest API interface documentation to the potential customer as well as your sales representative. So the contract will cover all necessary legal agreements between Fronius and the contracting party, as well as all information we need during the onboarding process. So each subsidiary has the right to contact template, which contains the correct creation information. So this will be the address of the subsidiary, place, and jurisdictions, for example. So the interface documentation, so this will be describing the functions of the API and how it can be used correctly. The second step will be once the completed and signed contract, which is between the sales representative and the customer itself. So as soon as the agreement has been made, both contract parties have to fill out and sign the contract itself. And there are mandatory appendixes, so described as annex in the contract. So for example, Annex 3, so this will be to please insert discounts if granted. Regarding the payment terms, a distinction must be made between new and existing customers. So for existing customers, the takeover and payment conditions are from BAN. And for new customers, they will add a 30-day net to the annex and also to BAN itself. So Annex 4, so this has to be completed by the customer itself. So this will cover personal details of the contact person, which includes their email address, as well as product information. New features changes will be sent to bank and account details, which covers on the email address for the invoicing. So all invoices are sent exclusively via the email to this email address that has been given. And then lastly, for Annex 4, so Solar.web API, the API will be unlocked for this account, but please note that the account must already exist before starting the onboarding process. Otherwise, the onboarding is not possible at all. So next is the third step. So this is the onboarding from inside sales point of view. So for the activation of the API access and automated billing process, the following steps have to be carried out. So we'll have to create and adjust the BAN account of the client according to the address data for the contract itself. We'll then activate the e-billing in the BAN and also deposit an email address from the field of email for invoicing for Annex 4. We will then create or adjust the CRM contact according to your personal data of the contact person for the contract itself. We'll then make sure that the SolarWeb user account is linked to the same CRM account as the contact person. So you'll have to be completely bound to that company, for example, via CRM and BAN itself to then make full use of the API. We will then add the completed contract, including the signatures for both parties in the CRM account. And also we will then add the contact person's email from Annex 4 to the emailing or mailing list, which is located in Satlet in Austria. From here, it will then be available in our CRM, for example, for any queries. Next is the fourth step. So this will be the activation of the customer inside sales. So the customer will have to go to a specific link for contact users to enable a new customer. We'll then add the new contact button, provide the customer's email address, enter the BAN account, which is the 3 digits that we are given. From there, it will set up a BAN account with up to 6 digits from the internal CRM system that we are using. You don't have to enter the company name, as this is automatically read out from the SolarWeb database if available. A contract may have a start date and an expiry date. So the start date by default is the current day. A contract may also start somewhere in the future, but not in the past. So you can only have the contract roll out from the day of signing, for example, or a specific date when the site is to be commissioned and to be fully operational. There is also an expiry date. So default, the contract duration lasts 2 years and is automatically renewed annually, unless one contracting party terminates the other contracting parties within writing of 3 months before the end of the contract period. So this means that it's not necessary to add an expiry date unless the contract is herewithin limited in time. So next is the fifth step. So this will be where the customer receives access to the rest of the API page in SolarWeb. So they will simply open SolarWeb, go to user settings, and they'll see the REST API tab. They'll then have to follow the following functions are available. So they'll do key management, so creating keys for the API. Data volume, so this will be to allow them to check the amount of query data within different time periods. So detailed instructions and described in the interface documentation. So quick notes on this. So the user interface only represents the technical implementation of a contract. You still need a paper contract for this. Expiry dates can be changed later if the customer renews the contract. And contracts without expiry dates are possible. They simply do not end. And also lastly is the customers are not receiving an automated email when enabled. Step number 6, so this will be the end of the contract. So if the customer cancels their contract, Inside Sales needs to update the contract's expiry date. For this, they'll press the edit icon next to the expiry date and change the date to the projected end of contract date. Step 7 is blocking a customer. So the lock icon appears on the right-hand side of each customer can be toggled. So when the state is toggled, the customer is blocked from using the Solar Query API. So reason why you may want to block a customer. So if the customer has not paid invoices for a couple of months, for example, blocking them prevents them from using the Solar Query API and creates some pressure to pay to them, make further use of the functions. If the customer misuses the Solar Query API, you may want to block them temporarily too. A valid reason might be too many database insensitive calls, which lead to a denial of service on the Solar Web itself. Step 8, this will be updating a contract. So the CRM ID and the expiry date of each contract may be changed using the edit icon. So it is not possible to change the user, so the email address or the start date. You can also cannot change a contract if it is already expired. You would have to create a brand new contract if it has already expired. Step 9 is the invoicing. So this is an automated process. Pillowweb counts the number of query data points in the time frame of 1 month. So depending on the amount, an invoice will be sent out automatically in the following month via email. There's no manual to DOS for invoicing. So please note for this, if a customer does not exceed the free amount of data points, he doesn't receive an invoice. So 0 invoices are not issued. So the posting key is equal to the sales of software such as 224. So again, going over the key management, so here you'll see the tab under user profile. Several keys can be created from this for the rest of the API. The next is the contract itself, the cost and sales regarding the Solar Query API. So how does the contract look like? So you may find the latest contract documents on the Solar Web Query API SharePoint page. So there are individual contracts for Fronius International and eSubsidiary where API is available. The reason is that the contacting party that creates the invoice has to be defined in the contract itself. So this will be including the correct plate of jurisdiction, for example. So for Fronius International, it'll be in Pettenbach in Austria. That will then be the jurisdiction for that Solar API, for example. So how does a contract look like? So the contract consists of the following structure. So there'll be the main contract, which includes all legal agreements between the Fronius and the contracting party. Annex 1, so this will be the interface documentation. In the course of handing over the contract to the customer itself, also the latest version of the interface documentation shall be handed over, as this is referred to in the contract. Annex 2, so this will be the service level and service communication. So here the responsible support contact for the customer is mentioned, which is always the national responsible technical support. So there is no API support service, for example. So it has to go through TSI, for example, for them to assist with any service that needs to be done. Annex 3, so this is the fee and the payment terms. So in this chapter, the agreed API prices are cited, included in the payment terms and conditions. So Annex 4, so this will be the customer's details. This has to be filled out by the customer and covers all relevant information that we need from the customer itself. So again, the email address, Solar Web IDs, for example, the physical site names, for example, devices to be used. So when to reroute a customer to the inside sales. So the questions will be related to invoicing. So the amount of the invoice, the payment conditions, and the dunning, as well as the contract relevant topics. So the contract terms itself, contract extensions, as well as if you're wanting to terminate your API contract itself. So SolarWeb Query API costs. So the demo access is free, but there are costs for unlimited access. So the cost depends on the number of acquired data points per month. Below is a list showing how the endpoints and data points are built. So the response to the following calls are not built. So this is release information, PV system information. So this will be the count of the number of systems, the list of system IDs, the count of devices, and the list of devices used. Each responsible of the following calls counts as one data point. So if this PV solar system information, so this would be detailed information about the system itself, detailed information about the devices in the system, power flow data, and as well as your current weather data, so your meteorological data. So again, the demo access is free, but there are costs for unlimited access. So the responses for the following call counts as multiple data points. So aggregation data. So this is per data point channel and timestamp. So this is such as your CO2 savings, which is 4 channels, counts as 1 timestamp. Profits, which is 3 channels, counts as 1 per timestamp, for example. The historical data. So this is per data point itself and channel and the timestamps. So example for an hour energy exported within 5-minute log intervals counts as 12 data points. Service messages, each service message counts as a data point. Your energy forecast, so this is for each 15 to an hour energy exported forecast, counts as 1 data point itself. And lastly, the weather forecast, so this again is 1 data point per day that is extracted. So for example, if you're using from 0 to 500,000 data points per month, it is then free. But if you're making use of additional data points that you want to extract from the Solar Query API, it'll then be a certain amount that is billed depending on how much data you're extracting from the query itself. So the data calculator, so again, this will be the number of system and devices. So here you'll state how many systems you want to extract from, how many smart meters are in the system, if you have an Ohmpilot and batteries and additional sensors. You'll then have the system related requests. So again, from here, we can then extract the detailed information about the system. So every call per month. So here we will then also have the power flow values of the system from the system. So this API call is done for every X amount of seconds or hours per day. It will then give you a data point per month that you're then extracting. Current weather, so this is number of calls per day that you're making. So again, this will also calculate a amount of data points that it is then identifying. Energy forecast and weather forecast. So again, how many days in advance? So you can do up to 7 days on the weather forecast, and the energy forecast is how many hours in advance. So it's up to 48 hours. And again, it will calculate the amount of data points that you're extracting regarding energy forecast. Historical data systems. So this is again is the number of channels so that you want to extract from the historical data of the system itself or the specific devices. It again relies on hours per day, so every X amount of minutes. So you can set it from anything from 15 to 60 minutes. You have that 1 hour time frame that you can set it. And again, this will calculate the amount of data points that you would be then effectively using per month with that specific task that you want to extract from the API. So next is the analysis of the customer's data usage. So in SolarWeb, you can simply go to user settings and the rest of the API is there. So this tab again has 2 views. You will then select the data volume. So here you get an overview of how many data points were consumed during the previous months. So users can also download a CSV file for each month. So here we get a specific amount of events that we want to carry out, for example, and as well as the amount of data points that we have called from that specific aggregated data months, for example. So here we can see the amount of data points that we have accumulated for that specific hour that you want to extract. So you get different types. So we have hourly details for total aggregates, the account ID. So this is the user SolarWeb account ID. This will always be the same ID for each customer. The system ID, so the PV system which was queried can be empty for some query types. The timestamp, so again, this is for the hour for the type equals hour, or the first day of the month, for example, which equals type equals total. So please note that the time information is provided in UTC time zone. Next is the event name, so which call can be empty for the last total aggregates, as well as the count event. So this is the number of calls during an hour for that specific hour for or for a month, for example, that we then creating. And next is the count data points. So again, this is the number of calls during an hour for that hour that we are requesting data from the API itself, or for the month itself in total, which is then given to us. For further information, recordings are available on our homepage. So operating and installation instructions are available on our Fronius website under downloads. On our YouTube channel, we have our how-to and installation videos, as well as any webinar recordings, as well as our dedicated Sub-Sahara Africa playlist, which is available at the link below. So your Fronius Solar Energy team, so regarding technical questions, trainings, Sales International, as well as after-sales service, and as well as our details are listed below for Cyprian himself, myself, Byron Kutzer, and then also our colleague, David Mwangi, who is DSA for Eastern African region. Really hope you enjoyed today's webinar. Appreciate it.